Hi, welcome to question 2 of the Leavens Cert Ordinary Level 2025, paper 2. So get stuck in. Now this is trigonometry. So part A says there are two angles, A and 2A, in a right angle triangle as shown in the diagram below. Now once we see that's a right angle triangle, there's two strategies open up. One of them is Pythagoras' theorem. But for Pythagoras' theorem to work, we'd need to know two of the three sides. Now this question looks like it's focusing on angles, so it's most likely to be the trigonometric ratios, sine, cos, and tan. And all sine, cos, and tan are the relationships between the angles and sides of a right angle triangle, and only works for right angle triangles. It's something that is fundamental to maths, and as long as you even if you don't fully understand what is going on, it's really testing your ability to interpret information, to use a formula, and to do the algebra to resolve it. Okay, so we'll get stuck in. Now, even from before the question is reaching up, I know that all three angles in a right angle triangle, or any triangle, should add up to 180. I know that in a 90-degree triangle, this is 90. So part 1 says, show that the size of the angle A is 30 degrees. So I know that 180 degrees is equal to A plus 2A plus 90. And that's what I've stated here in a mathematical way, just to frame my thoughts. And now I go, well, look, I can do a bit of work here. I can simplify a bit. Okay, so I add the A and 2A, and that gives me 3A. But I also realize that if I'm solving this, I want to know what A is. So this 90 is in the way. One way to get rid of something is to take it out. If I take it out on this side, I have to take it out on the other. Now I've created a little bit of a problem there in that I have to do a calculation, which is 180 take away 90 is 90. But on the right hand side, I've gotten rid of the 90, which is the whole reason I did that. Now we're sitting in a situation where 3 times some number gives 90. So you may just cop the answer as 30. Or if you want to use algebra, you can divide this by 3. Anything divided by itself turns into 1, so you've gotten rid of the 3. You're correct as long as you do that to the other side. 90 divided by 3 is 30. What some people might do is they go, the 3 is multiplied on the right. So when I bring it to across the equal, it turns into the opposite. The opposite multiplication is division. 90 divided by 3 is 30. So multiple strategies there, depending on which one you prefer. Now part 2 says the lengths of two of the sides are x. So we see here, we don't know what that is. And 10, as shown in the diagram above. Use A is equal to 30, and we've already identified that A was 30 from part 1. Find the value of x, correct the 2 decimal places. Now, normally in a situation where I'm asked to find the side, the first thing I'll try to do is use Pythagoras. But Pythagoras won't work here because I don't know the hypotenuse and I don't know the opposite. Okay, so one of the fundamental things in a right angle triangle is that the side opposite the angle, the right angle, is the longest side and has a special name called the hypotenuse. I actually hope I spelled that right. The next feature of a right angle triangle is that whatever angle you're focused on, and right now I'm focused on this one, the side opposite the angle I'm focused on is called the opposite. Now, the remaining side, okay, is the adjacent. So every right angle triangle has an opposite, but again, it's relative to the angle you're focused on. That identifies the adjacent. The static thing is always the hypotenuse, which is across from the biggest angle, which is 90 degrees. So therefore, it has to be the longest side. Now, I think I've read through the question. So we get stuck into the answer. Now, there's 3 formulas here, the trigonometric ratios, sine, cos, and tan. And all sine does is it relates for every single angle. It relates this side with this side. Literally, we've measured it. Now, cosine relates this side with this side. So for every angle or every triangle that can possibly exist, right angle triangle, we've written down what that relationship is. Now, tan relates the opposite to the adjacent. So the question you have to ask yourself is, which formula should I use that has the most information and that is most helpful? And in this situation, it's the tan formula. I'm looking for the opposite. I have the adjacent and I have the angle. Okay, there's three elements to this particular formula. Do I know the angle? Do I know the opposite? Do I know the adjacent? So what I'm missing here is the opposite. Okay, so I know that A is 30. I know that adjacent is 10. And now all I have to do is use algebra to simplify this into my answer. And I see here that the 10 is divided on the right. So when it moves across, it's going to become the opposite, which is multiplied. Tan 30 is stored in your calculator. Okay, and again, it just is for a right angle triangle that has an angle of 30. What would the length of the side opposite that be? Over the length of the adjacent, okay, which will always be the same when you're talking about a triangle, a right angle triangle. We recall the information and multiply it by 10, and then I got an answer of 5.773. But the question says, give that to correct the 2 decimal places, so 3 is less than 5. The number prior to it stays the same. Job done. Okay, so the next question, part B, says the triangle PQR is shown below. Some of its measurements are also shown. So they're not stating what they are. And I see here that the angle here, QPR, is 41. The angle here, PRQ, is 104. And they're giving me the length of the side opposite this angle, which has to be the biggest angle. It's bigger than 90. So I could work out what the angle here is. I don't know if I need to, but it would be 104 plus 41, which is 145. Take that away from 180, and that would be 35. Okay. There are two major formulas that you would expect to use with a non-right angle triangle, and that is the sine rule and the cosine rule. Now, the cosine rule works when you have an angle and two sides either side of it, and it can be used to find the side across from it. And that doesn't seem to be what's happening here. An alternative way the cosine rule would work is if you're given all three sides. And if you label it correctly, you can use them to find one of the angles. Okay, it's a more difficult question. This looks like the sine rule. Okay, and we might need to do a bit of work first, and that's labeling. Okay, so if this is the angle I have, I generally call it the angle A. And I look to see, do I know the side opposite it? And I do, and I call that little a. But then I'm looking for, do I know any other angle or side? And I do, okay. I know that big B, actually I confused myself there. I'm identifying this one as being big B, and this one as being little b because I'm being asked to find PR. Stereotypically, you'd be asked to find RQ, because you'd have more information. Now, I do have B, and we did it earlier. I need to do that calculation. Okay, so I know that little a is 11, big A is 104. I'm looking for PR, that's B, but big B, I can find it by doing the calculation I did earlier on, and from 180, taking away the 104 and taking away the 41, which gives me 35. So for this formula, I know 3 of the 4 things. This is solvable. Once I realize that and I input my numbers, okay, I have 11 over sine 104. And remember, sine 104 is just a number. And we retrieve it using the calculator. Is equal to B divided by sine 35, which again is a number. We've measured all of these triangles and we know exactly what the ratios are between the sides and the angles. They're stored in the calculator. This is a little bit tricky in that I need to do some algebra. Okay, so the sine 35 is divided on the right. When I bring it across to equal, it turns into the opposite operator and it multiplies by everything on the far side. Okay. Now this is one big chunky calculation, but the calculator will handle it. And when I put it through the calculator, I got an answer of 6.5. The units are centimeters, as I say that in the question, and that's my unknown side. If I run it through my BS meter, like 6.5 is smaller than 11. 11 has to be the longest side. There's a direct relationship between the angle and the length of the side. So if this is the biggest angle, then this would have the longest side. So my answer is less than 11, so there's no reason for me to be overly suspicious that I've made a calculation error. Now that's the end of question 2. So as always, if you want to copy these notes, just send me an email at shanetroy@gmail.com. Like and subscribe to get access to more playlists. Best of luck.